Hi, my name is Daniel Hummer, and I'm a postdoc here at the Geophysical Lab at the Carnegie Institution. And I'm going to be presenting a number of things at AGU, and one of them is work that I just recently completed as a postdoc at UCLA with Craig Manning and Abby Kavner. And we were looking at the properties of magma when you include carbon, when you include carbonate as part of the magma. So what we did was we took compositions that represent a carbonated mantle, compositions that you would find very deep in the earth, and put them together and put them under very high temperatures and pressures using this device that's in this photo here right beside me. And so these two things, these metal things here, are pistons that come closed down on our sample and put it under high pressure. We get several gigapascals of pressure this way, so we can put it under upper mantle conditions. And then we heat it up to about 1800 degrees Celsius so that all of the material melts. So we have basically a little tiny pocket of a real magma composition under real pressure and temperature conditions of the mantle that we can actually experiment with. So we have an X-ray beam. This is done at Argonne National Labs at the Advanced Photon Source. And we have an X-ray beam that comes through and scatters off of the sample and goes straight into this long detector that you see right here. And collecting all of those X-rays and analyzing the data tells us about the atomic structure of the magma, so we can learn what the chemistry is like inside the magma. And we also, because we also want to know what the physical properties are, we also conducted experiments in which we drop a tiny little platinum ball through the magma while it's at these conditions, while the material is molten, so that we can find out what its viscosity and its physical behavior is like. And I'll play the video, and there's a little platinum ball up top there. And as material starts to melt, you can start to see bubbles form, and the ball flies off camera, but then it drops quickly through the magma, and then it starts circulating. It's bouncing around there because of all the convection currents that are going on inside the cell. So you can see just from watching the little platinum ball move around that these are not the thick, viscous magmas that we're used to thinking about being inside the Earth. These are very fluid, liquid kinds of magmas with very low viscosities depending on what the composition is. So we tested this for a series of compositions and found that these viscosities depend very heavily on how much silicate versus how much carbonate you have. So I hope that looks fun, and I hope to see you at AGU, and thanks everyone for watching.